Hello, and welcome to this presentation on low-code application development with new Oracle Apex Service. My name is Todd Botker, and I'm a PM Director in the Database Developer Tools team at Oracle. I'm excited to share with you what's included in Oracle's recently launched Apex Service, how you can get it, and a brief demonstration. At the end, we'll wrap up with a summary of service packaging and pricing. Let's first cover what's included in this new cloud service, Oracle Apex Application Development, which I will refer to simply as Apex Service. I'll describe the key capabilities you get from its hardware and software stack, including Oracle Cloud Infrastructure, or OCI, Oracle Autonomous Database, or ADB, Managed Oracle Application Express, or APEX, and a managed middle tier. Starting at the bottom of the stack is Oracle's second generation Infrastructure as a Service and Platform as a Service cloud, which we call Oracle Cloud Infrastructure. It's built from the ground up for enterprises seeking high performance, low costs, strong security, and easy cloud migration. For our purposes, OCI is what gives Apex Service a solid and easy-to-use control plane. It provides a console UI where you can create, stop, start, terminate, and scale your service instances. The console also displays graphical metrics for monitoring and managing Apex Service. If you need to control Apex Service programmatically, OCI exposes public developer APIs and SDKs that enable automated management. OCI also provides cloud fundamentals such as service governance, usage reports, and billing. Above OCI, you get an Oracle Autonomous Database on shared infrastructure. It's a high-performance, converged database for managing diverse types of data. It is elastic, which means you can dynamically scale database compute resources to handle spikes in use. Plus, you get the benefits of Autonomous. ADB is the first and only automated database that will self-patch, upgrade, backup, troubleshoot with tuning, and more. This avoids countless hours of manual effort. With respect to Apex Service, there is very little that low-code developers need to do here. As the name suggests, the database is taken care of for you, so you can focus on building apps. Along with ADB, you get Oracle Apex. It enables citizen and professional developers to rapidly build and deploy modern web applications for mobile and desktop users, all from within a browser. We call Apex a low-code app dev framework because very little to no coding is required. Developers can drag and drop predefined visual components into their applications, choosing from a library of incredibly powerful components such as interactive grid, faceted search, cards, and graphical charts, to name a few. You populate these components with data using SQL queries or calls to REST data sources. Because the Apex engine runs in database, where it's close to your application data, apps can be executed with maximum performance and scalability. As we'll see next, this makes your middle tier highly streamlined. Note that with Apex Service, you'll get a fully managed Apex instance. This means developers don't have to worry about configuring, patching, and updating Apex because it's taken care of for you. Developers optionally can defer Apex version updates for up to 45 days if time is needed to validate apps on a new version before adopting it. Importantly, due to this service's focus on Apex applications, it does not support Oracle Net Services or SQLnet database clients. If your app evolves to require SQLnet connectivity, then with one click, you can easily upgrade Apex Service to a full, standard autonomous database service with Apex included and SQLnet support. At the top of the stack is a streamlined middle tier. Its key function is to relay communications between browser clients and the database where Apex is running. This middle tier is fully managed by Oracle, which means, again, you don't have to worry about things like patching, upgrading, and tuning. Additionally, it provides developer tools that complement Apex, such as an optional REST interface to your data and a web-based SQL developer environment. With Oracle REST Data Services, or ORDS, running in the middle tier, Low-code developers can easily define custom REST endpoints to access their Apex application data. With SQL Developer Web, developers can graphically model data, author database SQL queries, and create database PL/SQL scripts. Now that you know the basics of Apex Service, let's discuss how developers can quickly get started using it. If you are a current Oracle Cloud Infrastructure customer and you already have an OCI tenancy and account, then start by signing into OCI, locating Apex Application Development in the OCI Service Navigation menu, and then creating a new Apex Service instance. I will demonstrate this in a moment. If your company currently uses OCI but someone else owns creating and managing OCI resources, then contact that person and request they create an instance for you. Ask them to forward the welcome email message that contains links to your new Apex service. Alternatively, if you are brand new to Oracle Cloud Infrastructure, or you want your very own OCI tenancy to experiment with, then you also can get started by signing up for OCI free tier at oracle.com/cloud/free. Upon completing a short sign-up process, you'll receive a free OCI tenancy and account seeded with free cloud credits that can be spent on paid services such as Apex Service for an initial trial period. Plus, you also get access to a set of always free services that are available for an unlimited time and do not require credits. After you've successfully signed up for OCI free tier and are signed into the OCI console, you should see a homepage that looks like this. From here, you can put some free credits to work by creating your own new Apex Service instance. Okay, next, I am going to change gears and take a few minutes to demonstrate Apex Service in action. I'll start by showing how to create and manage an Apex Service instance in OCI. Then, you'll see how to complete one-time Apex Workspace setup steps. Lastly, I'll demonstrate how to create, modify, and run a live Apex app. Beginning from the OCI console homepage, at the top left corner, let's click the hamburger icon to open the OCI Service Navigation menu. Scrolling down in the menu, we see a service category named Database-Related Services. Expanding this category shows Apex Application Development and Apex Instances. Let's click here to proceed. Now we see a list screen that shows Apex running in OCI. It is our main entry point into everything Apex. In this OCI tenancy, we see that Apex already is running in an Autonomous Transaction Processing database and an Autonomous Data Warehouse database. I could jump directly into Apex from here, but for this demo, let's create an instance of new Apex Service, specifically by clicking on Create Apex Service. This displays an instance creation dialog. Here we enter basic information including the instance's OCI compartment and its display name. We also enter a name for the underlying autonomous database. Next, we select CPU and storage resources. Let's go with a single OCPU and 1 TB of storage. I'll leave the auto scaling box checked, which enables Apex Service to automatically add OCPUs to our instance during periods of heavy load. Here we see the database admin password. I'll set and then remember this password. I need to remember it because we'll use it in a later step. Finally, we select whether this Apex Service instance should be accessible on the internet with optional enforcement of access control lists, or instead, placed inside of a virtual cloud network where only clients within the VCN can access it. We want our demo apps to be publicly and broadly accessible, so let's leave this set to allow secure access from everywhere. After finishing the dialog, we click the bottom button to commence instance provisioning. Immediately, we are taken into an Apex-specific details page that shows helpful information about our new service instance, including usage metrics, which will be populated later as we use it. This is the same details page that would be displayed if we drilled into an existing Apex instance from the list screen I showed previously. Notice that the status of our new instance initially displays as provisioning. After approximately 1 to 3 minutes, the state will change to available, indicating our instance is running and ready to use. Soon after the state changes to available, I receive a welcome message in the email inbox of the administrator for this tenancy. The message contains important information about our new Apex service instance, including direct links to its Apex administration services, Apex application development services, and SQL Developer Web. Back on the Apex details page, let's take a moment to talk about lifecycle operations for our instance. Lifecycle operations include things like instance start, stop, and terminate. To access them, first, I must drill into the underlying autonomous database. Here we see the database details page. Notice that database-specific information is displayed. For example, this is the version number of the database. To view a list of available lifecycle operations, let's click the More Actions button at the top. See how different operations are enabled or disabled depending on the database's current state. Clicking on Stop here would not only stop the database, but also my whole Apex service. We don't need to do that right now, so I'll click the More Actions button again to close the dropdown and proceed with our instance running. Back on the database details page, notice the link under Apex Instance, Instance Name. Clicking this takes us back to the original Apex details page where we started. Next up, let's talk about required one-time Apex setup steps. Before we start building apps, we must create an initial Apex Developer Workspace and user account. We'll be prompted to do that upon launching Apex the first time. Initially, I am prompted to enter the admin password that I noted earlier. Now I click Create Workspace. Here, we are prompted to enter a name for our new Apex workspace, a name for a new database user, and a user password. For this demonstration, let's enter demo for both the username and workspace name, set a password, then click the bottom button to continue. Okay, it looks like our new Apex workspace and user account were successfully created. This was all done in Apex Administration Services. Here you are seeing the Administration Services homepage, from which you can manage Apex workspaces, users, and more. Now we're going to sign out of Administration Services and go directly to the sign-in page for our new workspace. We enter the workspace name and user credentials that were just created, and then click Sign In to continue. This brings us to the workspace homepage where we can access Apex application development services including App Builder, SQL Workshop, Team Development, and App Gallery. Our one-time setup steps have been completed at this point. I can see that we have an instance of Apex service running in Oracle Cloud Infrastructure, a new Apex development workspace, and an Apex user account. Now, we're all set to create our very first Apex app. So let's jump right into App Builder and use a wizard to create new app. Here we will create from a file, which is a common way to build new apps. When creating from a file, Apex allows me to upload CSV, XML, JSON, or Microsoft Excel files and then build the app based on that data. I can also copy and paste CSV data or leverage sample data files that are included with Apex. In the Load Data dialog, let's click the Copy and Paste option at the top. Next, we click a drop-down box that shows a list of available samples. Let's go with the Project and Tasks sample data. Notice this data is automatically pasted for us in the text area below. From here, we can simply click Next. Now we see the inspected and parsed data. At the bottom of this page is a sample of actual table rows that will be created in the database. Let's set table name to project_tasks and click Load Data to proceed. We can ignore the prompt to select individual columns because we'll be loading all columns, which is the default behavior. After clicking Load Data, we see a spinner until the wizard finishes loading. Okay, this is the final Load Data screen. It confirms that 73 rows of data have been added into our new Project Tasks table. Now we can move on to creating an Apex app based on this table. Let's continue by clicking Create Application. Here we see new app pages that will be automatically generated by Apex based on the structure of our data. I can click the Edit button for a given page to see more details about it. Let's click Check All next to Features to include a broad set of Apex functionality in our app. And then, lastly, we click the bottom button to finish up. When the wizard is all done, we are redirected to the new app's homepage in App Builder. Clicking on Run Application here shows the app as end users will see it. First, the app requires a login. So far, we created only a single Apex user account, the initial user that was generated while creating the Apex workspace. We will use that same username and password to sign in now. While this is fine for demonstration purposes, for a real app, you should create distinct user and developer accounts, all with minimum required privileges. Okay, we're in. Let's explore our new app a little. We can click Dashboard, either in the sidebar menu or home menu, to view charts that were generated. We can click Project Task Search to experiment with faceted searches. Project Task Report shows an interactive report. Upon clicking the Edit icon for a given record in the report, we see record details in an editable form. Next, let's navigate to the Calendar page and review data displayed there. Finally, we can review the available settings under Administration. Excellent! We now have a fully functional Apex app. It was automatically generated for us by Apex. All we had to do was point to sample data and make a few settings. To conclude this demonstration, let's add an enhancement to the app. Perhaps we can improve its faceted search page a bit. Notice the status facet, which we anticipate end users will frequently use to report on status of projects, is located further down the page instead of near the top. Let's change this. Because we ran the app from App Builder, a special developer toolbar is displayed at the bottom of the screen. By clicking Edit Page in the toolbar, we can directly make changes to it. Here we see the Apex Page Designer. It is where Apex developers can build, run, and easily iterate on their application pages. There are 3 panes in Page Designer. The left pane displays a hierarchical list of page components called the rendering tree. The middle pane displays page layout, which is a high-level representation of the rendered page, and gallery, from which we can drag and drop visual components into the layout. The right pane is the property editor, where we can set attributes for a selected component. To move our status search facet higher up in the page, all we need to do is select it in the rendering tree and drag it upwards. Let's place it underneath Project. Then, at the top right of Page Designer, we click Save and Run Page to immediately see our change. And there it is! That was the last step of this demonstration. Now that you've seen Apex Service in action, let's close with a summary of service packaging and pricing. Apex Service consists of 2 pieces, OCPU and storage. Both are billed hourly. Adding up their costs, you can get an instance of Apex Service for less than US $360 per month. That's for 1 OCPU and 1 terabyte of storage, running continuously for a full 31 days. Now, 1 OCPU may seem like a small amount of compute power, but keep in mind this is running on Autonomous Database, where the database is tuned and comes with the extreme performance of Oracle Exadata. In practice, you actually can do quite a lot with an OCPU. Our internal tests show that each OCPU of Apex Service supports hundreds of thousands of application page views per hour. And if your apps exceed this, you can dynamically scale compute power up to 128 OCPUs. This packaging and pricing makes Oracle Apex accessible to low-code developers of all kinds, whether they're employed by an enterprise, working independently, or volunteering their skills. Furthermore, unlike low-code services from other vendors, with Apex Service there are no fees per application, per developer, or per end user. You have no limits on the number of applications that can be deployed, number of developers using the service, or end users that can use apps. Developers are free to deploy applications supporting thousands of end user accounts on a single service instance. Even data transfer into and out of the service is included in this base price. And best of all, as I mentioned earlier, you can try Apex Service completely free as part of OCI Free Tier. Well, I hope this information has been helpful. We're excited to bring you this new Oracle Apex Application Development Cloud Service. For more information about Apex Service, visit oracle.com/applicationdevelopment/apex today. Thank you.